The story of how the world changed doesn't start with a robot, a lab, or a genius in a movie-style bunker. It starts with something painfully ordinary: a graphics card meant for video games, a green logo, 3 letters, Nvidia. For years it was just the brand you picked if you wanted smoother frames in Counter-Strike or better shadows in Crysis. No one looked at that little chip and thought, this will be the heart of a future intelligence that rewrites the world. But that's how the most powerful things usually begin, quietly on someone's desk, glowing green under a dusty fan. In the 1990s, 3 guys, Jensen Huang, Chris Malachowski, and Curtis Preem, started Nvidia in a rented office. Their bet was simple: the future would need more graphics. Not philosophy, not politics, not grand visions of super-intelligent machines, just better pixels. The early years were brutal. Competitors collapsed. Chips failed, markets shifted. But Nvidia survived by doing one thing obsessively well: making hardware that could do thousands of tiny calculations at the same time. Back then, it was just for rendering light and shadow. No one imagined that same parallel power would one day be wired into neural networks trying to mimic the human brain. For about a decade, Nvidia was the gamer's choice. You didn't buy it because of AI, you bought it because your favorite YouTuber said this card slaps. The company's story was simple: make the picture prettier, make the game smoother. Then something strange happened, quietly at first. A small group of researchers realized that these gaming chips were good at something much more interesting than rendering: dragons and explosions. They were perfect for matrix multiplications, the brutal, repetitive math behind deep learning. In 2012, the famous AlexNet paper, the one that shocked the AI world, was trained on GPUs, not magical quantum computers, just repurposed gaming hardware from a company that still ran ads during esports tournaments. That was the first moment Nvidia stopped being just a graphics company and started becoming an infrastructure company for the future of thinking machines. Jensen Huang saw it coming faster than almost anyone, while the rest of the world still thought GPUs equals games. He started talking about accelerated computing, a fancy way of saying, if the future is math, we're building the engines. Nvidia didn't just sell chips. It built CUDA, a programming layer that turned those chips into a whole ecosystem. Researchers who wanted to train neural networks suddenly didn't just buy a GPU, they entered Nvidia's world. Drivers, libraries, dev tools, conferences, lanyards, and greenlit keynotes. Slowly, quietly, a dependency formed. If you wanted to do serious AI, you didn't go to a random company. You went to the one that made the tools and the silicon. Then came the gold rush. AI left the labs and stormed into big tech. Every company suddenly needed models to recommend, to detect, to rank, to optimize. Data centers expanded like a new industrial revolution, except this time the factories were racks of humming GPUs. Nvidia sold the shovels in this new gold rush, a 100s H100s DGX systems, each chip a brick in the invisible cathedral of machine intelligence. The stock price exploded. Analysts didn't just call it a good company, they called it the most important company on Earth, because if AI was the new electricity, then Nvidia was the one who made the generators. On the surface, this was a success story. A scrappy gaming chip company transformed into the backbone of the AI revolution. Tech blogs cheered. Investors worshipped. And Jensen became something like a rockstar CEO: leather jacket, story-driven speeches, memes all over the internet. But in the shadows of that success, something darker formed. Because while everyone talked about OpenAI and democratizing intelligence, the compute required to train cutting-edge models became so massive, only a handful of companies and a handful of governments could afford it. And almost all of them were building on the same silicon heart. This is where the story stops being just about performance and starts being about power. If intelligence is the new oil, then compute is the new pipeline, and Nvidia is the company that owns most of the pipes. Small labs, independent researchers, and universities suddenly found themselves priced out. Training a frontier model wasn't a PhD project anymore, it was a billion-dollar operation. The message was subtle but clear: if you can't afford the silicon, you don't get a voice in the future of intelligence. That's how centralization works. Not with soldiers, not with flags, but with access. Governments noticed. Defense departments realized that the same GPUs powering image generation could also run target recognition, drone control, and signal intelligence. Intelligence agencies saw the potential of scanning mountains of surveillance data through learned models. Regimes, democratic and not so democratic, understood that predictive AI could be used for monitoring, profiling, even pre-crime-style risk scoring. The underlying hardware, often the same, Nvidia accelerators, a company that started out making Quake look prettier, had become a critical supplier to the military, financial, and surveillance appetite of the 21st century. Then came the geopolitics. To make its top-end chips A100H100 and whatever comes next, Nvidia relies on some of the most advanced manufacturing on the planet. From fabs like TSMC in Taiwan, suddenly the supply chain of AI compute wasn't just a business detail, it was a strategic vulnerability. The US imposed export controls on advanced AI chips to certain countries, Nvidia had to make slightly nerfed versions of its GPUs just to comply with sanctions. The world discovered a new concept, silicon geopolitics. If one company's chips become the bottleneck for global AI capability, then that company isn't just a vendor. It becomes a strategic asset or a choke point. Energy joined the story, too. Training a giant AI model is not like charging your phone, it's like powering a small town. Rows of GPUs run for weeks, sometimes months, consuming megawatts of electricity, throwing off heat like digital furnaces. Cities started to notice spikes in energy demand. New data centers quietly appeared near dams, nuclear plants, and cheap power grids. An entire hidden architecture formed not of cathedrals and palaces, but of concrete boxes filled with Nvidia cards, inhaling electricity and exhaling predictions. We say AI runs in the cloud, but the cloud is just someone else's warehouse with Nvidia inside. Meanwhile, the story told to the public stayed polished. Keynotes talked about curing disease, self-driving safety, breakthrough science, and to be fair, some of that is real. GPUs are used in drug discovery, climate models, and robotics. There's genuine beauty in what accelerated computing can unlock. But every coin has two sides. The same hardware that enables medical breakthroughs can also power hyper-optimized ad-targeting mass manipulation. And models trained not on science, but on our most addictive impulses. The more effective the hardware becomes at optimizing patterns, the more tempting it is to use it for optimizing people. Jensen often says, AI is the most powerful technology of our lifetime. He's not wrong. But power does not arrive alone. It brings dependency. Banks depend on accelerated risk models. Startups depend on rented GPUs to train their products. Auto companies depend on AI chips for self-driving. Governments depend on accelerated computing for satellite analysis. Under all of that, you find the same vendor, the same architecture, the same silicon shadow. The bigger Nvidia became, the more invisible its influence appeared. Because it sits one layer below everything. Under the apps, under the models, under the headlines. Imagine for a moment, something goes wrong. Not a Hollywood-style robot uprising. Just a supply shock, a massive fab incident, or a geopolitical crisis blocking chip exports, or a critical bug in a generation of GPUs running half the world's AI models. What happens when the heart of AI skips a beat? Some recommendation feeds glitch for a day, or logistics break. Hospitals slow down, trading systems hiccup, defense networks lag, and governments realize that a single corporation's supply chain has become the nervous system of their digital state. That's not just market risk, that's system risk. None of this means Nvidia is evil or uniquely monstrous. That would be an easy story, and easy stories are usually wrong. What actually happened is more unsettling. A company chased performance, found product market fit, and rode that wave to dominance. In a world that didn't stop to ask what it meant to have one main supplier of machine intelligence, we built global AI as if we were building a new internet. But instead of open protocols and many competing hardware paths, we quietly accepted a more concentrated model. The result is not a villain, but a single point of failure baked into the infrastructure of the future. And yet, there is something undeniably mythic about Jensen's rise. The leather jacket on stage, the casual way he talks about trillion-dollar shifts, the calm certainty that accelerated computing is destiny. Too many developers, he's not just a CEO, he's the high priest of compute. People queue for hours to see keynotes, clap for chip roadmaps, and cheer benchmarks they'll never personally use. We used to gather in cathedrals, now we gather in convention centers, lit by lit, applauding new ways for silicon to think faster about us. So what does it mean to say Nvidia became the dark heart of AI? Dark not as in evil overlord, but as in hidden core. The heart is not the part of your body you show in selfies, it's the part you forget about, until it stops. Nvidia's chips pump compute into chatbots, weapons, ads, science, filters, face recognition, and fraud detection. When an AI responds to you, there's a good chance a GPU somewhere has burned a tiny bit of electricity just to think about you. You don't see it, you only feel the output. That's the definition of a shadow. Very real power, just outside the frame. The question isn't, is Nvidia bad? The question is, how comfortable are we with a world where the compute that shapes truth, markets, elections, and wars is funneled through a handful of vendors and a handful of fabs under a handful of flags? We've been here before. We centralized energy, we centralized media, we centralized banking. Every time, the same rule applies. When too much power sits in one place, the world eventually pays a price. The difference now is that the power isn't just over what we use, it's over how we think. There's still time to shape how this plays out. We can invest in alternative hardware architectures. We can support open tooling that doesn't lock researchers into a single ecosystem. We can ask our governments why they're building so much on infrastructure, owned and controlled by private companies. Most importantly, we can remember that compute is not neutral. It encodes choices about what is fast, what is slow, what is efficient, what is waste. Waste includes curiosity, slowness, doubt, and dissent. Then we've optimized ourselves right out of being human. Maybe, in a few decades, people will look back at this moment and say, that was when we outsourced too much of our future to a single architecture, or maybe they'll say, that was when we woke up and diversified. The heart of our digital civilization, Nvidia, will still be here. Chips will still be faster, silicon will still be etched in ever finer lines. The question is not whether the shadow disappears, the question is how big it gets, and whether we remember that the shadow exists because somewhere, behind all that metal and math, there's still a human hand drawing the roadmap, and that hand can change its mind. So next time you see a headline about the AI revolution, or a viral demo of some new model that seems almost magical, remember the quiet little piece of hardware, buried in a rack somewhere, churning away. Remember that behind every smart system is a stack of decisions. Who built it? Who profits from it? Who gets access? And who gets left outside the warehouse door? We don't get to vote on the chip design, but we still get to decide what kind of world it powers. If AI is the brain of the new age, then the silicon that runs it is the heart. And if Nvidia sits at the center of that heart, the least we can do is keep watching the beat.